Hello everyone, welcome back to JDCodebase. Today we are solving LeetCode 26, remove duplicate from the sorted array from the LeetCode top interview 150 list. And this problem is very important because it teaches in-place array manipulation, which is must-known concept for coding interviews. And the PPT slides and the full source code are used in this video are available in the video description, so you can download them and practice along with me. So you are given a sorted integer array called nums, and your task is to remove duplicate in place. Meaning you should not create a new array for the final answer. You need to return a value k which represents the number of unique elements. And the first key position of the array must contain the unique values, and the order must remain the same. Anything after index k does not matter. So let us understand this with example. In the first example, nums array is the 1, 1, 2, and after removing the duplicates, we only care about the first two positions. So the answer is the k is equal to 2 and nums is equal to 1 and 2. The underscore means we do not care about that value. And in the second example, nums has a 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. And after removing duplicates, k is equal to 5 and nums array becomes the 0, 1, 2, 3, 4. So always remember, we are not shrinking the array, we are only adjusting the first k values. So before jumping to the optimal solution, let us understand a simple brute force idea. The thinking is very basic. Since the array is already sorted, duplicates will be next to each other, and we can store only values, unique values in a separate array, and then copy those values back to the original array. This approach is not an optimal one, but it is great for the beginner to understand the problem. So here is how the brute force solution works. First we create an empty array called the unique. Then we traverse the given array nums, and if the current element is different from the last element we added, we push it into the unique array. And after the loop end, we copy all the elements from the unique back into the nums, and finally we return the length of the unique array. So let us try run this using the nums array 0, 0, 1, 1, 2. So at index 0 we see the 0, and we add it to the unique array, the first one. Then at index 1 we see again 0, we skip it, and at index 2 we see 1, so which is new for the unique array, so we add into the unique array 0, 1 now. And at index 3 again the 1, and as always 1 is already in the unique array, so we skip it. At index 4 the value is the 2, so we add into the array. And so finally we have 3 unique elements in the unique array 0, 1 and 2. So let us move to VS Code and write the code for this. So first handle the edge case. If the array is empty, we simply return 0. For that, if nums.length is equal to 0, then return 0. And after that, first create a unique array and a unique dot push this nums of 0. And here we create a new array and push the first element because it is always unique. Then we start from index 1 and compare each element with the previous one. For let I equal to 1, I smaller than nums dot length I plus plus, and compare the value. If nums of I is not equal to nums of I minus 1, then unique dot push nums of I. And in last we have to we have to copy all the unique values to the original array. For that, again start a for loop for let I equal to 0, I smaller than unique dot length I plus plus, and nums of I equal to unique of I. And now we copy all the unique value back to the original array. So in last we have to return unique dot length. So let's run this. Okay, this is just type a mistake. Yes, again run this. Yes, it accepted both the test cases, but this is not a optimal solution. This time complexity is a big of one, which is fine because we traverse the array once. But the space complexity is the big of one, big of n, because we use this, you use an extra array. This is the main problem with this approach. The question accept the big of one extra space, so this solution is not interview ready. So let's see the best and interview prefer solution. We use two pointer approach, pointer I and pointer J. Pointer I keep track of the last unique element and pointer J scan the whole array. And whenever we find a new value, we overwrite the next position and no extra array is required in this. So we start pointer I at the 0 and at the index 0, and pointer J start from I1 and moves forward till the n-1. And if nums of j is different from nums of I, that means we found a new value. So we increment the I and copy nums of I into the nums of j. And at the end, first I plus 1 elements are unique. So let's see the dry run for this. We have an array 0, 0, 1, 1, 2. And I is at 0th index, j is at 1 index. And means both the values are same, so we skip them. And again I is at 0th index, now j is increment, j plus means j is at second index, both values are different, so we increment the I and copy the value into it. So now I become the 1 and j become the 3 now, and at the both index the value is same, so we skip it. And now I is again same at the first index and j is at the fourth index, both values are different, so I plus plus and copy the value into the array, means change the value. So let's write the code into the LeetCode, and for that now first we see the handle the edge cases. If nums.length is equal to 0, return 0. Then write let I equal to 0. This pointer I keep track of the unique elements, and start a for loop. Let j equal to 1, j is smaller than nums.length and j plus plus. And pointer j scan the array. If nums of j is not equal to nums of I, then I plus plus and nums of I equal to nums of j. And when we found a new value, we move the I by 1 and override the array. And in last we have to return the I plus 1. So we return the count of unique elements in last. So let's run this. Yes, it accepted both the test cases, and the time complexity is the bigger one because single pass through the array, and space complexity is the bigger one because we are not using any data structure, just normal these index I and j value. And that is for the LeetCode 26, remove duplicate from the sorted array. Today we understood a beginner friendly brute force approach and the optimal two-pointer solution that interview accept. And if this explanation helped you, please like the video, subscribe to JDCodebase for more information from the LeetCode Top Interview 150 series. And all the PPT slides, source code, and practice links are available in the video description. Keep practicing, stay consistent, and I will see you in the next video. Thanks for watching.